All right, so we're talking about trig again, except this time from the perspective of word problems. And all they are is basically triangle problems, almost all of them. And it's just that they give you a situation to figure out where to draw the triangle and how to draw the triangle. But what I need to make sure is that you understand some real basics about solving them once they are set up. So like, let's say you've got it all set up and it comes down to something like this. 1 over x is equal to 43/70. You're going to have things like this. And this one's tricky because the x isn't in a normal spot. You can't just say, excuse me, focus. You can't just say like, oh, multiply by 70. Okay, that isn't a bad way to start, but you wouldn't be done. What can you tell me what the fastest way would be? Cross multiply. I agree. I like it. Are there other ways? Yes. But if we cross multiply, you're going to get it down to 70 times 1 is 70. X times 43 is 43x. You'll have one more step, which is what? Divide by 43. Okay, so cross multiplying is going to come up a lot. All right, but it's more in the context of something like this. Let's say it says cosine of 30 is equal to x over 42. Okay, in this situation, I wouldn't even probably need to cross multiply because cosine of 30, I know that one. It's got a root in it. Anybody do this one? Okay, if you didn't know it off the top of your head, you go off to the side of your paper, you go, this is 30, 1, 2, square root of 3. What's cosine of 30? Root 3 over 2. Okay, so this side right here is root 3 over 2. You see how it's a cross multiply thing again? Except, really all I have to do is get the x alone, and all I'd have to really do is multiply both sides by, what? 42. Now, would cross multiplying have still worked? Yes. You just add 2 steps, where I can just have 1 step here. So I'm going to multiply both sides by 42, and then I'm done. Just remember, when you do that, you're not multiplying the top and the bottom by 42. Just multiplying the top, yes, because this is like 42 over 1. Okay? And then I can do some cross-canceling. The 42 and the 2. 2 goes in there once, 2 goes in there 21 times, so it's really 21 root 3 would be my answer. And that's an exact answer because I haven't rounded the root 3. So if they ask you for an exact answer, that's an exact one. If you actually go all the way with your calculator and take square root of 3, you're going to have to round it. It goes forever, so you'll have to round it, and that won't be exact anymore, will it? So if you want an answer that's exact, leave the pi in it, or leave the square root in it. That'll make it exact. Also, when you're looking for exact answers in the test, you're supposed to use radians. Not that we can't use radians in a problem like this, or degrees. We can use degrees. In fact, I'm going to have you use degrees on pretty much all the problems. But if you're supposed to leave an answer as an exact answer, and the answer has to contain a degree or a radian, they really were looking for radians. Told you to put both, you were fine. Okay, so let's talk about a real-world triangle problem. Oh, wait a minute, one more thing. They set up these triangles a lot of times by using 2 words, angle of elevation and angle of depression. All right, and I can already tell that the turned off lights are putting some of you to sleep, so I'm going to get some of them back on. Not all of it, some of them. It's a compromise. Okay. Now, your angle of elevation or angle of depression, would you agree if a person is standing like this and looking straight ahead, that's like a horizontal line? Do you get what I'm talking about? Okay. Then if I do an angle of depression, do you get if you're depressed, your head might be down? Right? Okay, so they'd be like looking down, like that maybe. Then that's the angle of depression. Let's say it's a 30-degree angle of depression. It means compared to looking straight ahead, they're looking down 30 degrees. But here's the common mistake people make. Let's say that they want to draw a triangle because they're trying to figure this out. Don't talk now, please. And they think that this is the 30-degree angle. It's not. You've got to remember, that would be 60, yes. And you got to remember that the 30 is the angle of depression. Granted, you might want to use the 60 in your actual problem, but when they say angle of depression, they're not talking about this. They're talking about this, the one that goes with horizontal. All right, same with angle of depression. A couple reasons for this next story to be depressing. A person standing on the edge of the sinkhole and looking down at where their house used to be. Did you guys hear about this in Florida? It's kind of depressing. And how many of you have heard about this story in Florida just recently? Oh my gosh, that's only a few of you. I'll tell you, it's pretty dramatic. So here's the latest. His It's two brothers in a house. That's the main players in the story. And it's a true story, by the way. All of a sudden they hear this tremendous cracking, loud, crumbling kind of a noise, and a sinkhole had opened up underneath one of the two brothers' bedrooms. And his whole bedroom set, the bed and everything, including him, fell into the sinkhole. Okay, and it's not like super deep, but it's like medium deep. And the brother hears the brother in the hole is yelling for help. The other brother runs to help, and he jumps into the sinkhole, which is a little crazy, and he starts digging to try to get his brother out. And he kept furiously just digging because he swore he could hear him still, and yet, must have been really muffled and whatever. And he eventually gets hauled out of the hole by the cops and the fire department, who were there to try to save his brother. And they said, it's not safe. Let us do it. We're the pros. Let us get in there. So they went in. They couldn't find him. They still haven't found him. And they gave up the search. So he is still in the hole underneath the house. They've torn the house down piece by piece, and they're trying to continue to figure out what to do, but they don't think it's worth. They know now that he has to be dead. They've used their little sensors that they put out to see if there's any signs of life, any noises, any whatever. So he's gone, and he's underneath his house in the hole still. Isn't that incredibly depressing? It's I think that's the reason it caught the national attention, is that it's that could have happened to anybody. You could be just in your house, and all of a sudden a sinkhole opens up, buries you alive, and they never even find you. It's crazy, but it's true. Okay, so if you're having the angle of depression is, let's say, a 40-degree angle, it's really critical that you get which one that is. There's kind of two angles here then. Which one's the 40, A or B? A is the 40. Okay, what's B then? If A is 40, what's B? It must be 50 because the total would be 90. Okay, so now let's say this is where brother is. And next I'm going to say that the height, you're estimating as you're looking down that this height is 30 feet deep hole. Okay, and so that means from here to here is 30. And the question would be, how far is it to your brother? It's more than 30, obviously. Try to set up the trig for me. What of what? And I'll give you an example. This won't be right, but let's say I say sine of 30 degrees is equal to x over 30. That is totally wrong, but it'll be something like that. See if you can set up a little trig triangle for it. Note, again, you will not be using the 40, even though I gave a 40 in the problem, because the 40 just helped you see what the angle of depression was, which was this part, but we aren't even using that. All right, that's 30 feet. I've told you this was not right. I was just trying to generally say how you generally set them up. You need a function, you need an angle, you need two sides. So I could set up another wrong one. Tangent of 45 is equal to x over 30. Totally wrong, but the point is you need a function, you need an angle, and two sides. Okay, quiet please while people are setting this up. If you haven't already set it up and written it down on the paper, I'd like you to do that right now. All I'm asking you for is x. Are you saying after you've got x, how do you find the other one? If you don't understand how you find the x, that's okay. I'm going to show you how in a second. But if you don't know how to set this up, I just want to see who's got it and who doesn't. All right. So how many of you got the little formula set up? Raise your hand if you do. Okay, a lot of people are seeming confident. Here's what you should have said. You should have said, from the 50s perspective, that is the angle in question. We need a function here. To figure out what function we use, like sine, cosine, or tangent, we got to look and see what do we have. We have the hypotenuse and we have the, what's that? Adjacent. Which one uses adjacent and hypotenuse? Cosine. And so now we do adjacent over hypotenuse. I'm just putting little tiny letters in there to remind me what goes where. The adjacent is 30, so I'm going to get rid of the a there and put a 30. The hypotenuse is x, so I'm going to get rid of the h, put an x. And there's my equation. Raise your hand if you set it up right. Good. The last step is you actually take the calculator, you type in cosine 50, and this will be a number. You'll put that number right there. Then we cross multiply. Grab your calculator. If you haven't already got one out, grab one. You can borrow one of mine. You can leave it on your desk during lunch. So come up and borrow it now, please. It doesn't have to be graphing, but it has to be scientific, as in has to be able to do sine, cosine, and tangent. Next thing on your graphing calculator, make sure you are set to degrees. Many courses later, we're going to ask you to set to radians all the time, but we usually use degrees in here. So go into the mode and make sure you're in degree mode. Otherwise, all your answers will be wrong. It's very depressing. That's true, not as depressing as being swallowed by the earth. So you go to cosine of 50. And did you get 0.6427? All right. I'm going to round it a little bit. That's fine. If you're only off by a teeny bit because of rounding, it won't be a big deal. Notice I got to cross multiply now, putting this over 1. Now this is 0.643x equals 30 times 1, which is 30, and then I divide by 0.643, but 46.7. Thank you. All right, so that means it is about 46 feet to your brother. All right, so, and I want to bring this up just because this guy's first reaction is like a lot of ours, which is to jump in and try to save, and that's really good. In Minnesota, that can get you killed in a couple situations. Here's one. Yep, on the ice. Somebody breaks through the ice and you want to like go and help them. You go right up to the edge of the ice and you like reach out. What's going to happen? You're going to go right in there with them. Okay, and the thing you often don't realize is that after only about a minute, you are completely useless. You can't move your arms anymore, barely. You can't raise them over your head for sure. You're just like so tired and you're so cold and you can't move. So you might think, you might feel all strong, like I can help. 1 minute from now, you'll be just as you'll be in really bad shape like they are. So you can't do that. Don't jump in to try to help and just get killed. Same thing with somebody drowning. It happens all the time. The only way that might work out is if it's a small kid, and you can jump in if they're really small. Like you could fend them off if they were thrashing and trying to grab you and stuff. Only if they're really small, maybe you'd be able to handle it. General advice is just simpler. Don't ever jump in to help somebody who's drowning. You got to throw them something. You got to get the cops or somebody to come and help you, somebody who's capable of doing a rescue like that. Because it's your first intent. It's the guys. I could have very easily seen the story going. The brother jumps in to save other brother, and then both of them end up in the hole, and both of them are dead. And I'm not saying you should just stand up at the top and like cry. You should be doing things to help, like trying to throw something down there or throw a rope down there. Get other people to come and help who have earth-moving devices and. But anyway, dangerous. It's a good question. Main thing is try to throw them something that floats so they can grab this thing that floats and then they'll settle down. If you have a life jacket on, that might change the equation a little bit because they might be able to be dragging on you and you might still float enough. But I don't know. It may be if you're trained, but I just wouldn't want to like give that advice to not know what they're doing. There you go. If you're a lifeguard, absolutely. I'm sure they have methods that they can use, but I'm sure they warn you about get too close to them and they will just drag you down. Oh, really? Gotcha. Cool. All right. Not going to go into more lifeguarding advice, but it was interesting for me here. All right. Not anymore right now, John. We get to move on to the more trig, because otherwise I'll eat up all your work time, and that won't be good. All right, of course, there was angle of depression. There's also angle of elevation. Here's one where you're standing on the ground, and you're looking up at a plane. And I know that's happened for many of us. We've been looking up. It's kind of a scary stick. I'm going to try that again. Why does he have 3 legs? Anyway, we're looking up at a plane, and the plane is like here flying overhead. Do you get that of the angle options, when they say angle of elevation, it's that one. Let's say that's 45. Okay, that's not a good choice because this other one would have been 45 also. But anyway, it's that angle. Then let's say that there's another plane that is in front of it, like here. Now all of a sudden I have two triangles at once, and the green angle is going to be different. I really encourage you to think of this as two completely separate triangles. There's going to be a black triangle here, like this, and then there's going to be a green triangle, which are completely different triangles. And then a lot of times they'll say, okay, how far apart are the planes? Then this little angle here, you can't find this out directly because you can't use this blue triangle because it's not a right triangle. So to find that distance between the plane, what you really need to do is find this distance, the longer distance, and then you find the shorter distance, which I'll pick a new color for, let's say purple here, that distance, and you subtract the red minus the purple, and you'd get the blue. Okay, so there's some setups that are like that. Next thing that I got to make sure you get is, what if they give you two sides and no angle? Yes, that can work to figure out the angle. I know if I had this was 3 and this was 4, I know that's going to be 5. But that's not the question. Well, what the question was, how many degrees is this? That's where you use inverse trig. I'd like you to draw this triangle for me on your paper. 3 and the 4, and the question is not how long is the other side. The question is, how big is that angle? You're not drawing. All right. Now, I want you to say, which one is it? Sine, cosine, or tangent? Which one can I use? Tangent. Tangent of theta equals what? 4 over 3. See how we set that up? You always have the angle here, which I don't know, and you always have the sides here. Now, how do I do this? You use inverse trig. How could I rewrite this as an inverse trig? I go tan inverse of what? Of 4/3. And that will give me theta. That's one other thing that inverse trig is good for. Okay, try that once. Inverse trig, or inverse tan of 4 over 3 in a fraction, like 4/3. Put it in parentheses, otherwise it might do it of 4, and then take the whole thing and divide it by 3. So put a little parenthesis here. All right, what do you got? So theta is 53 degrees. So in that 3, 4, 5 triangle you've seen drawn a million times since geometry, this was always a 53-degree angle. All right. Now, how about if we had another situation? Let's try to make it more real world. You are looking up at a tree. You know you're 100 feet away from the tree. Maybe it's a flagpole, because you're more likely to know how tall the flagpole was. Okay, so here's our flagpole. It's red because we just turned communist. Anyway, yeah. And then we know that the flagpole, we're 100 feet from the flagpole, and we know that the flagpole is 40 feet high. Then my question would be, how many degrees is that? Try setting it up. Try solving it and calculating. Hopefully you did. Tangent of something is 40 over 100, or you might have even been more advanced and jumped right to inverse tan of 40/100ths. $21.8. Thank you. There we go. Now theta is 21.8 degrees. Okay, one more. You are doing some extreme skiing, and here are the feet of the skis for your helicopter that you're in. There's the helicopter blade. And you're sitting right here on the edge of the helicopter, and you've got a rope that you know is 100 feet long, and it's dropped to the ground. Okay? And then let's say that there's another rope here that is hooked up, and that one's 70 feet long and that one's 50 feet long. What's the angle between those two ropes? Once again, all it is a triangle. Same kind of a problem. Almost unlimited numbers of ways to make triangle problems. And you'll see that in the packet. Unfortunately, there's 30 ways to make packet problems currently. We've got 30. And they're not all due tomorrow. We've got 15 due tomorrow and 15 the next day. And then Friday itself is the test on this. This is not new. This is just trig that's being used in a word problem. And just think of it this way. Last test was really easy. I think most of you know that. Overall, almost everybody got A's or B's. There's a few exceptions, unfortunately. But this last test could have been made a lot more difficult with a bunch of word problems on it. I think it's not a bad idea to have separated the two. So anyway, the word problems are coming this Friday. So here is how you would have done this one. First of all, you have to know this is a right angle or this whole thing wouldn't work. And then you're going to say, of that angle, I know the adjacent and the hypotenuse. So cosine of that angle, I don't know, is 50 over 70. Then I would do inverse cosine of 50/70ths, or if I'm really smart, 5/7, because the zeros can just cancel. So inverse cosine of 5/7, 44.4 degrees. Sounds good. So that must be about a 44-degree angle right there. Okay. So there's the basics that you need to know. Now let's actually do a couple problems from your packet. Before lunch, you'll probably only get the first one done. But here we go. Did you help by taking 7 out of that stack for your row? Here's an extra one. Yours is in this stack. Can you see if there's 5 in there? There you go. All right, let's start with number 1. Number 1 ends up being super simple. Wire at the top of a tower. So here's my tower. Towers pretty much go straight up and down, so that's how I'd start. Look, I got 2 sides right away. I got the ground, and I got my tower. And then it's got what's called a guy wire. It is, I don't know what that's short for, maybe guide wire or something, but anyway. That wire comes from the top down to the ground. And it says that it forms a 75-degree angle with the ground. That means the ground and the wire make a 75-degree angle. That means that. Now, I drew it really badly because that's nowhere near a 75-degree angle. Okay, so you don't have to go redraw your triangle, but you could if you wanted to. So then I go, okay, it's 75-degree angle with the ground means that angle down there needs to be pretty big, so I'm going to say that's 75. That's a lot better than it was before. And think about it, those wires to hold up towers, they're not, if this is the big tower, you're not going to want the wire to go way the heck over there. You're going to want the wire to pretty much go close to the ground like this. All right, so anyway, so you got your tower now with the 75-degree angle. It must give us one more piece of information or we can't do it. Where's that? So down here is 55. All right, good. So then, what do they want to know? I could either figure out the wire or the tower. Then I want T, all right? So I'm going to do my problem for that. I'm going to think, what do I have of 75 degrees, which is obviously the thing. What function should I use? Tangent. You're going to use a lot of tangent today. Tangent opposite, which is T, over adjacent, which is 55. And now I just have to use my calculator to get this and multiply both by 55. Wait, okay. So, remind me when you get back to help you with problems 2 and 4. Okay, we'll pause for now for lunch. All right, so here we go. We're back from lunch, and I wanted to help you with problem 2, just because I really don't like the question. And the reason that on number 2 that I don't like the question is that they give you extra information you do not need, and then kids go, but why did they tell us this information? You don't need that information to be able to answer the question. Okay, I'll continue. Oh, look at that. There's the bell. So I guess it wasn't even wrong to be late. Okay, so anyway, on problem number 2, do you get that there's 2 triangles there? One to the lower part and one to the upper part. But the way I read the question is, What is the height of the observation deck? Do you see the little deck sticking out? Do you get that that's the lower of the two triangles? And therefore the upper triangle just isn't necessary. So it's kind of a confusing question from that perspective. It's pretty much just use the 30-degree angle and the 200 feet, and you can figure out the side. Done. Okay, but it is true in the real world. You get lots of information. You got to figure out which information you really need to use. And just don't be confused. You don't need the 40. All right, let's move on to problem number 4. Let's do number 4 quick. Please draw the triangle for that one. It says a ramp leading to a freeway overpass is 470 feet long. This is a ramp, like driving up this ramp would be a total of 470 feet. So I got 470 going up. There we go. And it rises 32 feet. That means basically this must be 32. And of course that makes a triangle. And what didn't they tell me? They didn't tell me the angles. Remember how we talked about this, where if they don't tell you the angle, you can use inverse trig to figure that out. What angle do they want? This is important because there's 3 angles here. Of course, they don't want the 90 here. That would be too easy. They want one of the other two. Average angle of inclination of the ramp to the nearest tenth of a degree. Angle of inclination is from horizontal to that spot. Oh, skip past. All right, good, thank you. Is that one. So basically, you should set up. Is it opposite over adjacent? No. Which one is this one? Sine, yes. Sine of the angle is opposite over hypotenuse, 32 over 470. And then if I were you, right away I would move to inverse sine of 32 over 470, because that means the theta now has been put over there. Basically, that's the difference between option A and option B. They're both equations, but option B is solved for theta, and so I can just put it right in my calculator. So go ahead and do that, and you'll get your answer. And how many degrees was it, by the way? 3.9 degrees? All right. And if you ever do any, like, paying attention to these, you'd find that on the roads, they really don't want cars to be at a very steep angle. Having a degree like 15 degrees would be actually extremely steep for a car. Basically, you might be thinking in terms of like 90s and stuff. You obviously can't go 90. But even something like 60, completely crazy, couldn't possibly do it. I'll have to look up for you what the exact steepest angle of that a road can be and still be safe. But anyway, that's what we're doing, and you have to do problems 1 through 15 to be able to finish the packet by Friday. I will warn you, this packet will be collected. I will be putting it into the grade book. I strongly encourage you to do it. It is not due tomorrow, 1 through 15 by tomorrow. The next 15 of them by the next day. So they're due Friday. All right? Got a bunch of work time today and tomorrow then.